Next, we're going to look at how we can display categorical data in a graph. And the main way we're going to do this is in a bar graph. Just a quick note, you can use a pie chart to display categorical data. However, when you have lots of different categories, the pie chart becomes a little bit too crowded and it's difficult to compare the size of one category to the other. If we use a bar graph, we can avoid this. Bar graphs are going to be our way for displaying categorical data. We're going to use dot plots, histograms, or stem plots for numerical data. Now in a bar graph, each category is represented by a bar, and the height of the bar is proportional to the number of times the observation occurs. So pretty much the more results you get in that category, the higher its bar will be. The fewer results you get in a category, the lower its bar will be. A term that's important to note is Pareto chart. A Pareto chart is just a bar chart sorted from the most frequent to least frequent. So the tallest bar to the shortest bar. Displayed below, we have a bar graph. We have a class, and we've looked at what level they're at in school. We've got graduate students in class, just one graduate student. We've got 4 juniors in the class. We have 5 seniors. We have 3 sophomores and 7. We don't know what level they're at. This is a bar graph because it is categorical data. The result wasn't numeric data. The question was, what level are you at in your school progression? Are you a graduate student, a junior, senior, sophomore, something else? The responses weren't numbers, they were words, therefore it is categorical data that we have. Now, this is not a Pareto chart. If I wanted this to be a Pareto, I would start with the unknown very first on the left. It's the highest. Then I would have the seniors next. It's the second highest up at 5. Then the juniors at 4. The sophomores at 3. And last on the far right hand side would be the graduate students. A Pareto chart will end up looking like this every time. It looks like it's skewed to the right, but it's not. We'll talk about why in this next section. Histograms versus bar graphs. In a histogram, the bars have to be placed in order by the values they represent, the lowest to the highest. The lowest test scores on the left to the highest test scores on the right. The lowest times on the left to the highest times on the right. Bar graphs can be placed in any order. The bar graph above happens to be in alphabetical order. Again, we could have made it a Pareto chart, so it was unknown, then senior, then junior, then sophomore, then graduate. We could have placed it the opposite way. We could have gone low to high, so it would have been graduate, then sophomore, junior, senior, unknown. There's no set way in which to order a bar graph. In histogram, the bar widths are determined by the size of the bins, the bin widths. Whereas in a bar graph, the bar widths have no meaning. They just need to be the same width, the same size from left to right. And finally, one we've already discussed in the histogram video, histogram bars have no gaps. They always touch unless there's an empty bin. There was no data in that particular bin. With a bar graph, the bars will always have gaps in between. That's a giveaway that you have a bar graph and not a histogram. Now, there are certain things to avoid with your bar graph in order to give a good representation of what's happening. we need to make sure we begin the frequency scale at 0 every time. Note this bar graph, it starts at 0, then works its way up to 1, 2, 3, 4. But if you start that at something other than 0, it can lead you down the wrong path in making an improper decision. Another item to avoid is using symbols other than bars, using 3D shapes or using other shapes. It can be difficult to compare odd shapes, so just make sure they're bars. That should be an easy thing. And then make sure the bars have equal widths. You shouldn't have one bar that's wider or narrower than another bar. In this example, at the bottom of these notes, I have 2 bar graphs, and one of them is misleading. Say these are bar graphs because these bars are not touching their gaps in between. I'm looking at the number of crimes in millions in a city over a 4-year period, 2006, 2007, 2008, and 2009. Now, both of these bar graphs are displaying data from the same city, but one of them is misleading. If I look at the first one, the one in blue, 2006 crime seems to be high, about 1.32 million crimes. 2007 crime is still pretty high, about 1.32 million, just a little bit more. 2008 still around 1.32, but then there's this big drop off in 2009, so it looks like the city has done something with its crime problem. If I look at the one in yellow on the right, 2006 crime is pretty high, the bar is tall. 2007 it seems to be just as high. 2008 just as high, and then 2009 there's only a slight drop off. Well, using the bullet points from up above, the one on the left in blue is misleading. Its scale in frequency over here does not start at 0. This looks to be about 1.24 million. So in 2009, crime is still pretty high. It's 1.25 million crimes compared to 1.32 million crimes. That's not a huge drop off like the bar graph shows on the left. It's really just a slight drop off like we see in the one on the right. This is starting at 0. Other than that, things are good. We've used bars, no other weird symbol, and the widths of these bars are equal in both of the graphs. Make sure your bar graph starts at 0, you use bars, and that you have equal